All right, let me show you a couple of demonstrations about torque. Actually, this one's a little bit more advanced. We'll do that one second. I have a 100 gram mass here and a 200 gram mass, so this one weighs twice as much. So notice that if I put this here, okay, notice that the 200 gram mass balances a 100 gram mass, okay? Now the reason for that is, of course, that this is half the distance to the pivot, this is twice the distance to the pivot. So if we call this right here F times 2D equals 2F times D, all right? Then I could take this and put it the same distance. So obviously that's gonna move down, except that the bar is in the way there. If I actually left this, it would come down until it was vertical. But if I do this, notice that those balance, because this string is not pulling straight down. This string is not pulling perpendicular to the bar. And if we look at, and if I find the actual angle there, well, let's put this here so we can kind of get an idea of the angle. So that angle is 10, let me see, pretty close to 30 degrees. Can you see that? 10, 20, 30 degrees. And it turns out, if this is your angle here, if this is your angle, then that's the perpendicular component of that angle. The sine of 30 degrees is half. So only half of this weight is pulling downward. Only half of this force is perpendicular to the bar. The other portion of it is that direction. The cosine of 30 degrees, 0.866, is pulling that direction directly on the pivot and not causing torque. Next thing I'd like to show you, the right-hand rule. Easiest way to show that, firstly, is with this bar, and if I put this bar on a platform, right? Let me go over here. So, as viewed from above, this is counterclockwise, this is clockwise. Counterclockwise, clockwise. We use what's known as the right-hand rule. I put my finger here on the bar. Again, if there's no bar, you have to do this mentally. And notice my fingers are turning counterclockwise. This is it's actually undoing the bar. This is actually a positive torque because my thumb points up. Don't memorize counterclockwise. Actually use the right-hand rule and memorize that if I'm moving the object that direction, whatever direction it is, and my thumb points up, that's a positive torque. This would be a negative torque, okay? So therefore, on this bar, if I put a mass on this side, the bar will want to rotate this direction. The bar will pull down this direction. Wrap your fingers, the direction the force is causing the torque, and that would be a positive torque. If I put it on this side, it wants to pull down, that would be a negative torque. The other thing, of course, that torque does is it causes a change of rotation. We have a hanging wheel that has its own moment of inertia. Inertia, again, is that it doesn't like change. Well, moment of inertia means it doesn't like change of rotation. I put a mass on it, so now there's a torque. And right now it's not rotating. There you go. It's sped up because it has